Potentially nothing. All right, we got the test today, but we'll start out with, are there any questions?
Is
Oh, yeah.
it only just the test today, or do we have a lab too?
Did you want a lab too? Anybody want a lab today? Then I guess no lab today. Yeah, once you're done with the test, you may leave and dance in the hallway with delight, because that test was just what you wanted today. Yes.
Can you go over, I don't even know what it's called, but it's like three types
Okay, the plus minus 0? Did you want me to go over the ball problem specifically, or go over a problem?
Okay, yeah. The one for me
All right, so let's go over that one then. How far over I can go. Still being camera. Looks like let's see board. All right, so we're starting out with a situation like that. Just tilt it more. And we have something starting here at time A, and then there's time B, C, D, E, F, G, H, and I. These are moments in time. And so, also in the problem, I said it's sliding towards a wall to the right when it starts out. Initially, friction surface until it gets past time B. So there's friction here. And B has friction. Until it reaches, experience friction surface until it reaches the same point at time F. So F and B, at time B and time F, this box is in the exact same location. And it feels friction until time H, so friction is here also. And I say let the positive direction be to the right. Then I get into the specifics. The time A is when the box enters the problem, already moving to the right. Time B, the box feels the friction section of the floor while moving to the right. C, the last moment before the box is on the incline. And so C is off the incline right there. So C is part of the flat surface. D is the rightmost point before it starts sliding back. E, first moment just after leaving the ramp, and so E is also on the flat surface. F, first moment the box feels friction while moving this way, which we established already. G, with the time it's at its starting location. H, last moment before touching the frictionless ramp, so H is part of the flat surface, and then I, it stops. And oh, there we go. And then the origin is at this time right here. So this location right there is the origin. And that's given in the problem. Which format do you want me to do the answer in?
Brackets and parentheses. That's, I like
the
that.
second.
The second one?
Yeah.
Okay, which is also bracket parenthesis.
Yes.
All right, so we have position, displacement, velocity, acceleration. plus 0 minus. All right, so let's first start out of where's position equal to 0? At what time is position equal to 0? Okay, yes, and so the question is at what time is the box at the origin? And I think it was said
These are
F and B and F. Because at time F, the box is at the location again on the way back. So this is F and B. I find it convenient for at least the first three to figure out where 0 is, because you can't go from positive to negative without crossing through 0, or vice versa. All right, so if that's the origin right there, when is the position positive?
Going to the right?
Anything
Be
to the
careful
right
about
of
that.
B?
Pardon?
Is it anything to the right of B
Until,
until F?
yes. So it's anything between time B and time F, so all that stuff right there. Now, Luis, when you said going to the right, it's going to the right here from A to B, but that's not positive position. And from E to F, it's going to the left, but that is positive position because I'm on the right side. It's like I've got a number line here with 0 set right there. All that's positive, all this is negative. So it's positive from B to F. Now some students write it backwards and they'll do F to B. I treat that as between F and B is the same as B and F. Notice I have the parentheses here because F and B are 0. If I put the bracket, that would indicate that B is also included here, and B can't be both. And then negative, until,
A.
wait, from A to A, or only at A?
No, it said F to A.
Is it F to A? All right, so in terms of time here, we're cruising along here from A, B, C, D, E, F, G, H, I. So if you said F to A, that includes B, C, D, and E also. We've already identified that as positive.
Why?
Let's set up one of the other ones. So we have A between A and B, B between B and C, C between C and D. We can get out the I. I don't think I gave myself enough room. B, C, D, E. No, I did not give myself enough room. All right. So the single letter by themselves represents one moment in time. So A is at the very beginning of the problem. D is when at that moment that it's right there. The stuff in parentheses represents in between, because the box is moving from A to B. Point time A and time B just happen to be the highlights, but box does exist in between them. So when we're setting up position here, this would be the fourth format. So this is the progression of time A is the beginning of the problem all the way through I. So time H happens after time G, happens after time F, after E, and so on. So we established the origin is at time B, and at time F, it's in the exact same location. Then we said positive was in between there. Now, I think what kicked it off is, you had said from
After A.
F to A.
I see it now.
Okay, yeah, F and A would count all of that.
So how would you write that then in that format?
So in this format?
Yeah.
All right, so if we're doing everything else as negative, we have A to B with a bracket and a parenthesis. And then we have after F onwards, so after F to the end of the problem.
What? That ain't what I got, though.
So it's negative at the very beginning. And then after it crosses the origin again, it's negative again, so it's negative all along here. And so it's negative from F all the way to I, and then you put a bracket because I is included. I'm assuming that you can see that the board's, this board's not in the way.
Yeah, I can see
Okay.
it. Okay. So the bracket means what?
I'm
That
including
A-
that moment in time.
but B is not so much as included. But
B is not included here, because B is 0. B
Oh, I
is,
was talking about for the negative sign. No, I got it. I got it. Okay.
all right. Now displacement is very similar to position, other than displacement is relative to starting point. And so what is the starting point? And what other time is it at that same location?
G.
And so where is the displacement positive?
A to G.
Yep. Not including A and G, because that's where it's 0. So A to G. And where is it negative?
G and I.
Or in this notation over here, for displacement, it was 0 at A and G, positive in between. And then negative afterwards. And again, pointing out, sorry.
No, I'm just saying, I feel like that one is a little bit more, like, better to use.
And I was grading the 151 tests. Surprised at the number of people who use this notation. And by the way, let me emphasize, pick one of the formats, don't do all 4. And if you're gonna use all 4, please give the same answer in all 4 of them. There were 3 people in the 151 class who decided to do every format, and the answers did not all agree with themselves. I'm not talking about with other people. So from a grading point of view, when I see that, I basically roll my eyes, go, sometimes profanity slips out. And then I grade all 4 of them, and you get the average of all 4 of them. All right, so velocity. Where's velocity 0?
D.
Which, what did you?
D, letter D.
D, as in dog. Yes. D,
Would it be I to A and I?
yes. And in the problem, it states that it stops at time I. D, it turns around. I don't know if I explicitly stated that it stops at time D, but it turns around, so that's the point where it stops for a moment before coming back. So over here, this would be 0. And I is 0 for velocity. All right, so we have our zeros. Now we have, so basically we divided it into, well, we got this section and that section, so is this section positive or negative? Without the question mark?
Positive.
Yes. Because what determines the sign of velocity?
The direction
Of,
positive. Of the motion?
yes. So from A up to D, it's going that way. And that's the positive direction. And then it starts on strip backwards. Or negative. So that's everything else, so D to I. Not including D and I because it's stopped there. So over here, this would be positives and negatives. Questions to there? Amina?
So why is the displacement part positive from A and B to F and G?
Up to, didn't line it up particularly well. The problem, the displacement is about where the object is relative to where it started. The problem starts here at this time. So A is the starting time. So that's why A is included. That's why A is 0. And then it does, and now it's hanging out on the positive side of that. And it stays there until it gets to time G. That's when it's at the same location as time A. So that's why A and G are both 0.
Okay.
Is that sufficient?
Yes, sir.
Okay. Other questions? Isabella?
Why is A included on velocity?
Because it's already moving to the right when the problem starts. It's stated in the problem that it's moving to the right at time A. Other questions at the moment? Ethan?
So for position and displacement under A, why is position negative but displacement 0?
It's all about the reference. And for position, it's where's the origin? And I defined in the problem that the origin happens at this time right here. It's at the origin at time B and time F. And so anything to the left of that, it's negative. Anything to the right of that is positive. So that's why A is negative for position. Displacement cares about where it is relative to where it started. Well, it started here. And so anything to the right of that is positive, anything to the left of that is negative, but its displacement is 0 here, position is 0 here. It's like having a number line with the 0 and positive and negative, and then you just line 0 up with the origin for position, and then you just take that number line and shift it over to the starting point for displacement. Is that sufficient? Okay. Other questions before we hit acceleration? All right. Acceleration. I'm going to tackle acceleration a little bit differently than I think I've done. All right, so let's just assume that time A is moving to the right at 20 meters a second. I just need some number, 20, going that way. And it's going over a friction surface here. There's friction, so is it gonna speed up, slow down, or stay the same?
Is,
Yeah, it's gonna slow down. So 15, I just picked some smaller number, going to the right still. At time C, how fast is it gonna be going there? Why, what would cause it to slow down between B and C?
Oh, there's no friction right there, so it wouldn't be slowing down.
So it's going 15 here. Still moving to the right. Then we know at time D, it's 0. And now we start moving, now we start going the other way. Now, if it lost 15 meters per second going that way, and there's no friction, it's gonna gain 15 coming back the other way. So at E, it's going 15 this way. At F, it's going 15 this way. Oops. We have some consistency here. Now it hits friction again, so at G,
It's slowing down.
all right, so I'll just make that 10. Going to that way. At H,
It's slowing down more.
so H, so say 5. And then at I, it stops. So these are just made up numbers, but relatively correct. The fact that it slows down, stays the same, slows down, gains speed, stays the same, slows, slows, slows. In this region right here, what's the change in velocity?
Sorry, a second? No, sorry.
Unless I missed a word. How do you find change? Besides looking at the couch.
-5 meters per second.
Yes, negative. 15 minus 20. I didn't hear the negative.
Because I didn't say it.
All right, so between A and B,